Hello everyone. As we already discussed about the identities, now the point is what is the use of these identities? As I already told that if in case we want to multiply 102 by 104, we can use the identities. If we want to multiply the larger numbers, let's say a number 993 has to multiply by 889. In this case also, if in case we use our identities, it becomes very simple. And here the answer will become 882777. Now, how I am solving this is by using the identities only. To this I am writing 1000 minus 7, and to this number I am writing 1000 minus 111. And if we solve this in our mind, then automatically the answer comes out to be 882777. So basically this is one of the use of identities. Another can be if I am writing a polynomial this and I want to divide this polynomial by a binomial x plus y. Now, if in case we do not know that these are the this can be written as a perfect square, then definitely we will solve it like x plus y and x square plus 2xy plus y square, and we will go for the long procedure. Here we know that this is a perfect square and it can be written as x plus y whole square, because the identity says that x plus y whole square is equal to x square plus 2xy plus y square. And here again it is x plus y. So the power of 1 can be cancelled out the power and the answer comes out to be x plus y. So directly we can solve the question without going into the long procedure of division. So when we say identity, we understood that this is a perfect square. Now we will talk about what is basically the perfect square. As we know in the numbers, 16 is considered to be perfect square because it can be written as 4 square. 36, 25, 9, all these numbers are known as perfect squares. When we talk about the algebraic expressions, then what exactly the perfect square is? We know that a square plus b square plus 2ab, this is basically the format of a perfect square. We can replace x and y variables with a and b, that is no issues. In different books we are getting x and y, and in other books we may get a and b as the different variables. So this is basically the first term square, this is the second term square, and in between you are having twice the product of first term and the product of second term. Then only this is known as a perfect square. This can be with a positive sign and this can also be with a negative sign. Now the question arises that 4x square plus 25xy plus 9y square, whether this is a perfect square or not. Now we have to see that the first number has to be written in the format of first term whole square, and this can be written as 2x whole square. The last term can also be written as 3y and whole square. Now the question is, if the middle term is twice of 2x the first term and 3y the second term, then only this is a perfect square. If we multiply these three, it will come out to be 12xy. But instead of 12xy, we have 25xy. So if in case from this number or from this algebraic expression, suppose I subtract 13xy, then this will become a perfect square. So basically, this was not a perfect square. If we subtract a monomial 13xy from this expression, then it will become a perfect square. So we should understand that when a particular algebraic expression will become a perfect square, or it may become a perfect cube, or it may be having 3 different variables instead of 2 variables like x and y. When I talk about 3 variables like a plus b plus c whole square, Again, there is one identical thing to this, that is a square plus b square plus c square plus 2ab plus 2bc plus 2ca. This is also known as another identity which are there in 3 variables instead of 2 variables like x and y in this case. So if we have a larger term in 3 variables, this can also be written as the perfect square having 3 variables in it. Here what we are saying is that either we can use it in the division format. There is one more possibility of using this in the case of LCM and HCF. If in case we have a complete equation, we have to divide it into different factors. For example, I am saying 6 square minus 4x plus 4, and I want to write it in the perfect square format. It is x minus 2 whole square. We can directly put it this way. But instead of this, if instead of 4 there is some other term, so it may be a possibility that we are putting them as a factor of x minus a and x minus b instead of x minus a whole square. So this is how we solve the identities for the further solution of algebraic expressions. Thank you.